Welcome back. Before we get too far along in writing the code, I want to talk a little bit about the strategy of building an object-oriented application, or in this case, an object-oriented game. We want to break the project into pieces, and each piece is going to be an object. And for the most part, you want these objects to be very limited in their scope or their concern. And so we're going to first create an object which represents the entire game and put that into its own file. Then we'll create another object, which is the tic-tac-toe board itself. Now, there's going to be a temptation to try and put a lot of capability and a lot of functionality into each of these objects, but we're going to resist that temptation and make sure that the game handles only things having to do with the game. And some people would call this the controller, and that the board does nothing more than represent what would be a tic-tac-toe board. We're not going to put logic in the board for like moving pieces around. We're not going to put logic in the board for doing computation of the next move, things like that. The board has one purpose, and that is to keep track of where the pieces are on the board and to display that on the screen. And likewise, our X and Y markers or pieces are going to have their own capabilities, their own concerns, and they're not going to be concerned with figuring out where their next move is. Their only concern is, where am I on the board and how do I draw myself? Again, we're going to try and keep our objects very small and have their concerns be very limited. And by doing this, we're going to make our game much more extensible and easier to manage. Let's take a look at the code. The first piece of code we're going to look at is the main program, main.js, and all it says is create a new tic-tac-toe object. Mind you, in the past, we've looked at object-oriented programming, and we normally do a new function to create the tic-tac-toe object. And in this case, I'm going to use what's called a factory pattern. I'm not going to go into the details of a factory pattern today, but I can tell you that it makes our lives a little bit easier when creating new objects, because it allows us to return an object that is slightly modified from what the constructor will give us. Don't be alarmed when we see factory. All it means is we're creating a new tic-tac-toe object. Let's take a look at that game object and what it does. We're going to create our playfield, and we see this playfield back here. This is our canvas. And then we're going to call the init method of our parent, which is the playfield object. We're now letting the playfield object initialize, and then we create our board. And I'm going to put this bit off for just a second and then come back to that. Let's see if this much works. We'll refresh. I don't see any errors down here in the console. We're looking good so far. This really is the most trivial thing that we can do at this point, which is just to get our playfield started. We've created the game, which manages all of our pieces. It's going to be the controller. It's the central hub of all the activity of the game, and it initializes the playfield. That's all it does. The next thing we're going to do is we're going to create a board. And as I said, the board has only one function, and that is to keep track of the pieces on the board, redraw the board. I'm creating these manifest constants that we can be used all over the application, rather than try and remember that we're using a capital X, capital O, and a period to represent the three values that can go in a tic-tac-toe board. What I'm going to do instead is use these constant values. This gives me a little bit of flexibility, and that if I decided for some reason to change the data structures, I don't have to change all my code. I just change the value here, this value of X. Likewise, empty. And also, I think it's a little more descriptive when we're reading our code to see the word empty as opposed to see a dot, trying to remember what a dot means. When we initialize this object, when we create the board, we get our arguments. We call the init method of the parent object, which is the playfield object. We pass arguments up being the playfield that we're going to be playing on, the name of this object, its default color, and then its XY location and its width and its height. And so this is at the 0, 0 location, the upper left-hand corner of our playfield. And then it's the same size as the width and the height of the playfield. This entire playfield represents 512 by 512 pixels. And so our board is the entire playfield. Now, the other thing I'm doing is that each little square in our tic-tac-toe board is what I'm going to call a cell. And each cell then is 1/3 the width and 1/3 the height of the entire playfield. And so I compute that here. Don't be over concerned about this math.floor function. This just makes sure that when I divide something by 3 that it's rounding down to the nearest integer. I don't want my width and height to be a floating point variable. It causes some problems when we do graphics. Now, the third thing that we want to put in here is a model of our board. Rather than try and keep track of where the X's and O's and the empty spaces are by actual objects on the screen, what we do instead is we create a model of what the board looks like. And that's what this little bit of data is. This is our data structure. And what we're going to do is put a period every place where there's a empty square, a capital X, any place that there's an X, and a capital O, any place there's an O. The other thing is that you can see this is an array of 3 rows, these 3 rows here, and 3 columns vertically. And when we eventually we're going to need to write some methods to extract rows and columns and even diagonals from this. To draw this, we draw 4 lines. One 1/3 of the way over vertically, another one 1/3 of the way, 2/3 of the way over vertically, and then 2 more, each 1/3 of the way and 2/3 of the way down. And that's what each one of these lines does. And see how handy it is that we kept track of our cell width and our cell height. It's definitely making it easy to make this drawing. At this point now we have created our board and we've created our game. I'm going to add the board into the game. And you may notice that nothing's happening. And if you remember from the experiments we did when we created the playfield graphics system, I forgot to start the game. I forgot to start the playfield. And we notice that I passed the tick value in here. I'm going to pass it in as an argument here. Okay. There we go. Now you can see that we've created our boards. Even though this looks like we've drawn on the backdrop or on the canvas itself, what we've really done is created an object which represents the tic-tac-toe board. Now let's start creating the X and O markers that are going to represent the players. Tune in for that coming up next.